Welcome to this demonstration of the new VirtualZ Computing PropelZ product. We've heard from our customers the need to provide a simple means to automate copying data from IBM Z to a variety of cloud and customer data center databases and data lakes. In particular, non-SQL sources such as file system-based data force users to purchase and implement expensive, complex, or cumbersome multi-platform data pipelines. We created the new PropelZ product to address this need in a very simple, usable way. PropelZ can be used to quickly and easily create a copy of mainframe data, such as vSAM files, and load that data into hybrid cloud environments where you can use your familiar database and BI capabilities. We use a well-known and widely used method known as JDBC, or Java Database Connectivity. JDBC was created to allow Java programs access to relational data in a uniform way that is compatible with nearly all industry standard or newer emerging database servers. Just as a quick example, here is a partial list of the database products that support JDBC. These should be familiar names, but this is just scratching the surface of what is possible. Because we use JDBC, PropelZ can load data into any of the databases with a simple configuration change to locate and access the target database. Let's take a look at how this works. First, we'll review the sample dataset we'll be using in this demonstration. vSAM, unlike databases such as DB2, does not embed any information about the structure of the data, commonly known as metadata. Relational databases store the structure of the data, including table and column names and column data types. vSAM and other file access methods on IBM Z are described by external artifacts, such as COBOL copybooks. Furthermore, the data encoding format used on IBM Z, EBCDIC, is not standard on most cloud and distributed servers. Unix, Linux, and other distributed systems such as Windows servers use ASCII or Unicode variants such as UTF-8 as their storage format. Automated data transformation is an extremely powerful feature that VirtualZ provides out of the box. Data being retrieved from IBM Z by a client running on Linux or Windows can be automatically translated into a suitable format. The complications for doing this include not only the code pages, EBCDIC to ASCII for example, but also the native data types and field formats that are used by datasets on IBM Z, such as packed or zoned decimal, various binary formats, date-time formats, etc. The VirtualZ data transformation capability can read COBOL copybooks or other formats such as user-created XML documents to understand the structure of the data. We can then fully transform the data field by field during the data transfer. Now the data can be easily accessed in formats that can be understood and manipulated by applications and users on Linux or Windows operating on cloud or customer data centers. Now, back to the demo. We've logged into our mainframe, and the first thing we'll look at is the COBOL copybook that describes our demo data. This copybook furnishes the metadata that we'll use to understand the structure of the file, including field names and data types. We see a mix of character and binary fields, including some double precision floating point numbers that could be used in calculations, or in this case, geolocation. The file contains data about all the world's airports. It's a medium to large data set containing about 76,000 records, or rows in relational database terms, with a total size of about 100 megabytes. We can look at the vSAM file using IBM's File Manager to see the airport information that is contained in the file. We can also display some information about the vSAM file type. In this case, it is a KSDS, or key sequence dataset. We can see that it contains 76,358 records. Going back to the data, we can scroll through the records or display them in a hex dump format. Here we see that the first field is binary, and the character data is stored in EBCDIC format, as is usually the case for data on IBM Z mainframes. Now let's take a quick look at our configuration options for PropelZ. We have switched to an IBM Z Unix System Services shell session to view our configuration. This is also where we will execute the PropelZ Java command line. The first thing we see is our configuration file that describes where we are going to put our data, the database type, and connection info, including user credentials. Finally, we can see the configuration for the data transfer and database table population. These are default values that will just work out of the box, but if you want to customize these, it's easy to do just by editing this config file. To be clear, you will get a reasonable and useful result without changing these options. One further point before we move on. Notice the array_table line in the config. This is another type of automatic transformation that PropelZ provides. COBOL programs commonly use occurs clauses to store repeating fields embedded in VSAM records. SQL requires the repeating fields to be available as rows in a separate table related to a main table. PropelZ will automatically extract the repeating fields and create the expected tables and relationships so SQL queries can easily process them. Let's now invoke our command line. We've logged into our mainframe using SSH or Secure Shell. We use a relatively simple command line. This can also be embedded in a script for repeat or automated execution. We enter the command with some options, such as our config file, the name of the VSAM dataset we will copy to the target database, and the name of the COBOL copybook we'll use to drive the transformation. As we execute the command, we see some progress indicators on the screen. As the command starts up, it accesses the VSAM data, connects to the target database, runs the transformations, and begins to send it across the network in efficient batches of records. The command completes fairly quickly, and we get some statistics about the execution, including the number of rows inserted into the database, which matches the number of records in the VSAM file we previously viewed. We also see elapsed time, CPU time consumed, and the number of rows inserted per second. As you can see, this is a very quick and efficient process. Now let's go look at the results. We'll first take a look at our cloud MySQL database using the MySQL Workbench. On the left side of the screen, we can see that the database contains a table called Airport Demo, which is the name we specified in our config file. We can expand the columns and see that the columns are named the same as the field names that appeared in our COBOL copybook that we looked at on our IBM Z mainframe. Inspecting the details of the resulting columns, we can see the MySQL data types into which we transformed the EBCDIC character data in IBM binary formats. The character data has been transformed to UTF-8, a common Unicode format. We see our integer and double precision floating point fields as well. If we run a simple select *SQL query, we can inspect the rows and columns of data that we inserted in this table. The data is returned exactly as we expected. All of the records that were present in the VSAM file are now represented as table rows and columns, and we can see the data have been transformed into the expected data types: UTF-8, character data, floating point longitude and latitude, etc. We'll use SQL capability to filter the data to a subset of the rows. If we insert a where clause into the query, we can select just the data for a particular airport by airport code, in this case LGA for LaGuardia Airport in New York. We run the query, and now we see just the single row for that airport. Now let's take a different view, using a more end-user-oriented BI reporting tool. Here we see the data selection view of Tableau, a popular BI tool that is integrated into Salesforce CRM. We've connected a Tableau session to the same MySQL database we populated from the IBM Z VSAM data that we saw earlier. We can see the same airport table and column names we viewed in the MySQL Workbench. But now let's take a more useful view of the data than just rows and columns. With the power of graphical business intelligence provided by Tableau, and indeed by many similar BI and reporting tools, we've selected an out-of-the-box map explorer and populated it with our airport data. Using the latitude and longitude columns, we can precisely place all the airports on the map. As we hover over an airport location, we automatically get a handy pop-up with details such as airport name, city, URL, and other details. We have various filters we can use to further tailor the display. If we want to also see airports that can accommodate seaplanes, with a simple click of the selection criteria, the map immediately updates with that additional information. We can also leverage the geographical information to quickly add the medium and large airports in Mexico, for example. It is easy to see the value and ease of use of this approach to accessing and obtaining mainframe data on demand under end-user control, rather than complicated and expensive data pipelines managed by overburdened data center staff. You can provide your users the data they need, and just the data they need, with a few easy steps. Thanks very much for your time and attention. please go to virtualzcomputing.com to license and download a limited-use production copy of PropelZ. You can also reach out to us through our website, email, phone, or social media to obtain an unlimited annual subscription license.